Hello students, welcome to the lecture of discrete mathematics. Earlier in my last lecture we have done with the introduction to discrete mathematics and in the syllabus of this subject what we are going to study that we have discussed in my last video. Today in this lecture we are going to start with the set theory and under set theory, our first topic is what is set. After that, subset and proper subset, etc. and so on. We will study all the topics one by one in all the videos. So first, what is set? Set is an unordered collection of objects called elements or members of the set. So that means, for example, capital S is a set and under this we have so many number of elements or members is a collection of objects of any sort. Now, what is the meaning of this definition? We will see. Our set is a collection of objects of any sort. What is the meaning of here? Any sort? Any sort means it's the combination of different type of elements. It may be integer, it may be alphabets, it may be strings. So it always depend on the type. For example, here S is a set. We always denote the set in curly brackets. Now, this is the set of numbers. After that T, it is a set of alphabets. Next set is, we can say K. Here, number 1, that is a string. Second is the number. And third one is the alphabet. Now, what we observe here, it is the combination of three things. String, second is number, and third one is alphabet. Our major point is here set. It's not necessary, it's the combination of numbers only. Means only the homogeneous elements it contains. No, it's not the necessary condition. Second, in the second example again it's the collection of alphabets, means all are of the same type, all are homogeneous elements. But by seeing the third example, that is set K, through this example what we have observed, it is the combination of different types of data. One is string, second is number, third one is alphabet. So that is the collection of heterogeneous elements. Next point is that these individual are called elements or members or objects. So that's what about this set. Here two symbols are there. This is the belongs to symbol and this is does not belongs to. What is the meaning of this symbol? We will see it with the help of example. Our S is a set of alphabets, that is A, E, I, O, U. So this is the set of vowels. Now, we will see in detail about these notations, that is belongs to. See, small a, is it belongs to the set S? If it exists in this set, then we can say that yes, it is true. It belongs to this set. But see, is this X belongs to the set S? No, because X element does not exist in the set S. So we can say that it is does not belong. So that means the statement originally it is true, it is false, but now it is true. Now, I hope the meaning of belongs to and does not belong to is clear to you. If any element belongs to the set, then we are using the symbol belongs to. If any element does not belong to the set, then we have to use the symbol does not belong. Next, this is the example of the set which contains the element 2, 3, 5, 7, 11, 13, 17, 19. Again, this is also a set. It contains the codes of your subject. For example, UCS 405, UCS 520, UCS 303. It is also a set. Now, set is a single mathematical object and it can be the element of another set. So, how we can say that it can be the element of another set? See, this is one element. Just this is another element, this is another element, this is another element, this is another element, this is another element. So that means we can say that it can be an element of another set. Next, we can also represent the set in this way. See X in A such that X satisfy this property P. This is the property P. Now see here, X is a prime number and X value is less than 1000. X is a real number and it lies in the range -2 to 5. Now see in detail here. X is a prime number and X is less than 1000. Now how we can write out this? See, for example, name of the set is A and in this set it is a prime number, right? And its value is less than 1000. So that means what is prime number here? Prime number will divide it by itself or other than that it will divide it by 1. So the definition of prime number is it divides itself or either by 1 only. 1, 3, 5, 7, 11, 13 till how much it contains the numbers? Till 1000. I think so prior to 1000 which one is the prime number that we can write it use it as the ending limit of this set. Now it's not possible we can write out all the numbers. We can write out in short form always, that is X is a prime number and X is less than 1000. Next, these are the example of sets. Some well-known sets are set of real numbers R, set of all complex numbers C, set of all integers Z, set of all positive integers Z plus. Empty set is denoted by phi or the empty curly braces. The set with no elements or zero number of elements, we can say that. Next example is set of all polynomials with degree at most 3. What is degree here? This is the degree, that is at most 3. And set of all n-bit strings. Next is set of all triangles without an obtuse angle. Set of all graphs with 4 nodes. See here, total 4 nodes are there. So this is the example of sets. Next, membership. Now, in the case of membership, in case of set theory, occurrence is not important, and even you can see it with the help of this example A, B, C. Here I am writing C, B, A. So that means occurrence is not important, ordering is not important. Here only the ordering gets changed. Rest elements are totally same. Now here you can see A exists 2 times, B exists 2 times, B occur 2 times and A also occur 2 times and C occur only once. So meaning of this thing is ultimately our set is A, B, C. So that means occurrence and ordering of the set is not important. The most basic question is that whether it belongs to that or not, does not belongs to that particular set. Now see here, recall Z, it's the set of all integers. So what we can say, 7, yes, it's an integer. Is it belongs to Z? Yes, it is true. 2 by 3. Is it true? Means, is it an integer? No, it's not an integer. So it is false. Next is P be the set of all prime numbers. Is 97 is a prime number? Yes, it's a prime number. So that is true. 321 does not belongs to P. Why it is there? Because if we are considering it as belongs to, then it is false. If we are considering it as does not belongs to, then it is true. Now consider it here. 321 does not belongs to P. See, 321 is divided by 3. So that means it's not a prime number. So if again we are considering it as belongs to, then it is true. Then it is false. If we are considering it does not belongs to, then it is true. Let Q be the set of all rational numbers. 0.5, yes, it's a rational number. Root 2 does not belongs to Q. Yes, it's not a rational number. Now the point is that we will prove this later on in the further videos. You will see moving further. Now some of the sets we can say those are well-defined sets or homogeneous sets. Some of the sets are not well-defined or we can say heterogeneous sets. See it here, set of even numbers. So that means it's a common category. All the numbers are even numbers. So either it may be positive even numbers or it may be negative even numbers. So that's what about this set of even numbers. These are well-defined numbers, or we can say that homogeneous. Set of odd numbers, set of prime numbers, positive multiply of 3 that are less than 10, that is 3, 6, 9. Now you can see can also be set of numbers that does not have any common property, or we can say heterogeneous elements. See it here, 236, 828, 3839, 8827. The point is that in the whole set there is no common property. Same way other sets are also there. Moving further, example of sets, those are well defined. A set of even numbers between 1 and 15. What is the answer for that? 2, 4, 6, 8, 10, 12, 14. B set of multiple of 5 between 8 and 28. So what is the answer? 10, 15, 20 and 25. Now set name we can denote it by a capital letters. It may be denoted by a capital letter as we have used. Now this is the assignment, or we can say this is the list of questions which we are going to do right now. See how we are going to do it. Which of the following are well-defined sets? So right now you just have to perform this assignment, solve this set of questions along with me. All the colors in the rainbow are these are well-defined set or not? So in the rainbow, I think so only 7 colors are there. So that means that is the well-defined set. Yes, it is the well-defined set. If any of the set is well-defined set, I'll put tick. Otherwise, I'll put cross. See, all the points that lie on a straight line. Lies on a straight line means we can say this is the straight line and so many number of points are there. So that means that is also a well-defined set. All the honest members in the family. So I don't think so that is the well-defined set, because answer get varies. Some of the members are honest, some of the members are dishonest. So it's not the well-defined set. All the consonants of the English alphabet, yes. Other than 5, rest all are consonants. All the tall boys of the school, no, that's not the well-defined set. All the hardworking teachers in a school, some of the teachers are hardworking, some of the teachers are not hardworking. So that's also not a well-defined set. Even in the case of tall boys, we are not going to specify it, how much height. After how much height, we can say that boy is tall or that boy is not tall. So that is also not a well-defined set. All the prime numbers less than 100. So prime numbers less than 100, just think over it. Less than 100 prime numbers are 1, 3, 5, 7 and so on. C. This is the answer. So that means that is a well-defined set. All the letters in the word geometry. So that is also a set. Only repeated numbers we are not going to write out. Rest all we will write out in this way. G, in this way, then E, then O. Repetitive number we are not going to write out. That is the representation for the set, and that is the well-defined set. Now we are moving with the answers. What is your answer? 1, 2, 4, 7 and 8. These are well defined. So these are the answers. So I hope with this video you understand the meaning of what is set, and after that what are well defined set and what are not well defined set. So that's what about this lecture. In the next lecture, we will move further with the Cartesian product of a set. After that, we will study subset, proper subset, and so on. Thank you very much.